In this video, we're going to compute the limit as x goes to 0 of the arctangent of x over x. We can do this limit in many ways. Okay, and we can use our sense to get this limit. In fact, we know how to graph the arctangent. So here we're going to focus only on the positive part. So this is the arctangent. Okay. Here, this is pi over 2. And x is always bigger than the arctangent, but they get very, very close. When we are close to 0, we can distinguish between them. Okay, therefore this ratio is close. Okay, the arctangent and x are very close, and therefore this is 1. So this limit is 1. So this is one way. So this is one way of getting this limit. Clearly, we see that we can't distinguish between this function and this function here when we get close to 0. Okay, try to graph it, and you will have difficulty distinguishing between them. Another thing that we can do here is that we can use L'Hopital's rule. Okay, look, when we plug 0, we get 0 over 0, and this is an ideal candidate for L'Hopital's rule. Another thing that we can see here is that we can apply the definition of the derivative, okay, here at 0. So given the f of x is arctangent of x, we want to compute the derivative at 0. So f of x minus f of 0 over x minus 0. So here the limit, let me write it here, the limit as x goes to 0 of this one here. So it's gonna be our function is the arctangent, and the arctangent at 0 is 0, and x minus 0 is just x. And we see here this is the limit. Okay, this is the derivative at 0 of our function. Okay, so here we know that this one is when you know the derivative of the arctangent is 1 over 1 plus x squared. When we evaluate at 0, we get 1. Okay, so this is one way of getting this limit as well. Okay, another thing that we can do is that we can accept the following. We can accept that when the arctangent is close to 0, we can treat the arctangent as some polynomial that we can write as x. Okay, and here we can divide both sides by x, and we see that this is 1. Okay, therefore this limit is just 1. Okay, and another key idea that we can do is we can do a change of variable. Okay, if we let arctangent of x to be y, then the tangent of the arctangent of x is tangent of y, and this is just x. Okay, so this gives us that this limit of arctangent of x over x as x goes to 0. Here, when we change the variable, when x goes to 0, the arctangent will go to 0, and therefore y will go to 0. And arctangent is y, and x in this case is the tangent of y. Okay, do we know this limit here? Okay, to see this limit, okay, let's rewrite it. Let's rewrite 1 over tangent of y. So we have y over sine of y times the cosine of y. So I had to write tangent of y as sine of y over the cosine. Now, if I take the limit, I know that this one will go to 1, and this one will go to 1 as I take y to 0. Okay, remember that this limit y over sine of y times the cosine of y as y goes to 0. Okay, here I can rewrite this one as 1 over sine of y over y times the cosine of y. Okay, remember here, this one is known. It's a very famous limit. So this is 1 times the cosine of 0 is 1, and this gives me 1. Okay, so no matter what we do, we always get the limit as 1. Okay, so here, these are many ways to prove that this limit is 1. Okay, are there any other ways? Yes, there are many. We can do it geometrically using the arctangent, or we can use the mean value theorem for the arctangent. Okay, but this is enough since we have done many different ways to finding this limit.